Yes, so we looked at a technique. We looked at what is called static hashing. Although I've mentioned dynamic hashing in the slides, I'll talk about it a little later. And so in static hashing, what are the, so let's look at what a hash table is, what operations we would like to perform on the hash table. So the if you're looking at so the primary operations are insertion of keys, or rather elements, into the hash table, and removal of elements from the hash table. And insertion, or even removal or extraction of elements from the hash table. Not extraction, I won't call it extraction, let me call it retrieval. Retrieval of elements from the hash table. So when you look at a hash table, it's actually like an array. We already saw that example. And as we said, we define a hash function, h of x or h of key, which maps to a location in this table. Now, these locations are what we call buckets. And each bucket can hold S elements. That's what we said. Now, what happens if the, let's take, going by that example which I talked about, suppose each bucket can hold only 2 elements, and we saw this example with G, A, and G. Now, suppose a word gun comes, what will it do? Then clearly there is no space in this bucket to hold this. So what we do is, there are, so what we have is these are what we call collisions. And how do we resolve it? There's no space here. There are 2 kinds of hashing. One is called open hashing, sometimes also called direct chaining. And there is one more technique called, this is called, you have separate chains. And what you essentially do is the following. So you hash this to this, and then what you do is, there's no place for this word. So you go through this and see if these have elements. If they do not have elements, the first one that you come across, you put gun there. So during search, what will happen? It will hash to this guy, and then it will search sequentially and find wherever this word is. Alternatively, what you could also do is, you can create a separate chain like this. You could create a separate chain where all the elements, for example, what you do is, you don't, you keep an array of lists. Example, you can have an array of lists. Each element of the array corresponds to a bucket. And here you keep all the hashed elements. Okay, so notice another application of this over here. Something like this is what you could have. And so the question is, let's say I want to access this element. Then this is an order 1 operation. I come very quickly here. Then I have to go through this chain 1, 2, 3, and 4 probes to access this particular element. So hashing can be quite expensive. Okay. If you have a very good hash function, it will try to uniformly distribute the keys well. The important point is we don't fill the hash table. If the hash table can hold, n items as the size, then you may load it with something like m, and m by n is actually the loading factor of the hash table. Okay. Now we will look at this. The analysis is a little bit involved, and we will see how we will perform this analysis in a little while.